Alright everybody, so today we're starting on chapter 10, and the first section is about trigonometric ratios. And our objectives are to find the sine, cosine, and tangent of an acute angle, and then use trigonometric ratios to find side lengths and right triangles and to solve real-world problems. So our vocabulary for the day is trigonometric ratio, sine, cosine, and tangent. Alright, so for sine, of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. The cosine of an angle is the ratio of the length of the leg adjacent to the angle to the leg of the hypotenuse. And then the tangent of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent to the angle. Alright, so make sure you pause, you get the symbols and the diagram down. Okay. Now, just to make sure you don't get confused when you're working these out, in trigonometry, the letter of the vertex of the angle is often used to represent the measure of that angle. For example, the sine of angle A is just written simply as sine of A. So don't let that confuse you when you don't see the angle symbol. Alright, so 1A. Write the trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth. Remember, hundredth is two numbers after the decimal. Alright, so cosine of A. Alright, A's right here. Alright, so remember, cosine is the adjacent side over the hypotenuse. Alright, adjacent means next to, so that'd be 24. The hypotenuse is 25. 24 over 25 is 0.96. Alright, now we need to do the tangent of B. Here's B, so remember, tangent is opposite over adjacent. 24 over 7. As a decimal, that's 3.43. Example 1C, sine of B, so remember sine, opposite over hypotenuse, 24 over 25, which we did earlier, is 0.96. Okay, moving into example 2, use a special right triangle to write tangent 45 as a fraction. Alright, so remember in a 45 triangle, the two sides opposite the 45 degrees are the same length. Does not matter which 45-degree angle you choose. Opposite over adjacent will be S over S, which simplifies to 1. Alright, example 3, all of these you will need your calculator. Okay, so make sure you have your graphing calculator or your TI-30 because you can do trigonometric functions, or sorry, ratios on there. Alright, so tangent of 11, you put that in, round it to the nearest hundredth, that would be 0.19. Sine 62, plug it in, you get 0.88 with a 2 following it, so 0.88. And then cosine of 30, 0.86, round that 6 to a 7, 0.87. And now the hypotenuse is always the longest side of a right triangle, so the denominator of a sine or cosine ratio is always greater than the numerator. Therefore, the sine and cosine of an acute angle are always positive numbers less than 1. And since the tangent of an acute angle is the ratio of the lengths of the legs, it can't have any value greater than 0. Alright, so example 4. The first one, find DF. DF is our hypotenuse. We're given 51 degrees and 17. Alright, 17 is opposite that 51. We're trying to find the hypotenuse, so we'll need to set it up as sine. Okay, sine 51 equals 17, and you can put x here if you want to. Okay, now set this up as a proportion, cross multiply. Alright, and then you'll divide here. You'll get DF equals 17 divided by the sine of 51, which rounded is 21.87. Okay, now find the length round to the nearest hundredth, so we're finding ST, which is right here. We got 42 degrees, and we've got 9.5. Now 9.5 is the hypotenuse, and this ST is right next to 42, so we're going to be using cosine. Okay, so we're going to need to set this up as cosine over 42 equals x over 9.5. Alright, if we set this up as a proportion, all we'd have to do is cross multiply. 9.5 times the cosine of 42 rounded gives you 7.06. Alright. Right here, we need to find BC. Alright, here's AC, here's 18 degrees, and here's BC. Now, if we look, this is our hypotenuse, AB. So we're not going to be using cosine or sine, so we need to use tangent. Okay, we've got 18 degrees, we've got 12, and we've got x. Since that 12 is opposite 18 degrees, you're going to need to set this up on the next slide as tangent of 18 degrees equals 12 over BC. Remember, you can replace that with x, cross multiply, and then divide, which you will get BC equals 12 divided by the tangent of 18, which simplified gives you 36.93. Then right here, we've got to find JL. We've got 27 degrees, we've got 13.6. All right, now x right here is opposite 27. Opposite and hypotenuse, we're going to set this up as sine of 27 equals x over 13.6, pardon me. Remember, they put JL right here. When you cross multiply, you'll be left with JL, and then 13.6 times sine of 27 degrees, when simplified, gives you 6.17. All right, guys, good job. Make sure you write down any questions that you have. Have a great day.